This problem is target number 4 from the 2016 Sycamore Math Invitational. Target number 7, actually. And when we do this one, it's a conditional probability problem. And what a conditional probability means is you're given an additional condition that narrows what you know to be true. And the assumption is all the possibilities have the same likelihood at the end, all the different ways that you could select this committee. And since that we know that it's got to be at least 2 boys, we don't consider any of the possibilities that have 1 boy or 0 boys. And so our numerator comes from there being at least 2 boys and at least 2 girls, both conditions being met. But our denominator comes from just the at least 2 boys. And you can either do it as probability of at least 2 boys and at least 2 girls over the probability of at least 2 boys, or as a counting problem. I'm going to do it as a counting problem. So we consider all the cases. First is 6 choose 2 times 9 choose 3. That's 2 boys, 3 girls. And we're using just basic combinations here. How many ways can I select 2 of the 6 boys? How many ways can I select 3 of the 9 girls? When you do those calculations, you get 15 times 84, which is 1,260. Then the next case would be 6 choose 3, 3 boys, and so only 2 girls. And so that's going to give you, well, 6 choose 3 turns out to be 20. And then 9 choose 2 is 36, so that gives you 720. And then 6 choose 4 times 9 choose 1, which is going to give you 15 times 9, which is 135. And then finally you get 6 choose 5, 9 choose 0. That means selecting all boys. Well, there's just going to be 6 ways of doing that. So when you add all those together, you get 1260 plus 720 plus 135 plus 6, which gives you 2121. So our denominator is 2121. There's 2121 ways of having at least 2 boys. Those that meet our condition are those that have at least 2 girls, which would be these top 2. The bottom 2 do not meet the condition. If you add those together, you get 1980. Turns out that both of those are divisible by 3. If we divide both those by 3, we end up with 660 over 707. And that is the correct answer to this problem. Knowing that at least 2 of them are boys, there's a 660 over 707 chance that at least 2 are girls. And that makes sense because, you know, getting 4 boys and 1 girl and 5 boys are not very likely. There's not many cases of being able to do that. So it makes sense that you'd have a very high probability of, if there's at least 2 boys, then there must be at least 2 girls.